K.M. Shashank, studying in Information Science and Engineering in Sri Venkateshwara College of Engineering, Bengaluru. Welcome to my new video. In this video, I am going to discuss on the topic of IC engines from the course of Introduction to Mechanical Engineering. Let's move to next slide. Introduction to IC engines. Internal combustion engines convert fuel into mechanical energy. They are widely used in automobiles, motorcycles, and various machineries. Understanding their working principles is essential for engineering and automotive fields. Types of IC engines. There are two main types of IC engines. One is spark ignition and the other one is compression ignition. Spark ignition engines use a spark plug to ignite the air-fuel mixture, whereas compression ignition engines rely on the heat generated by compression to ignite the fuel. Working principle of SI engines. SI engines operate on Otto cycle, that is, which consists of four strikes, namely intake, compression, power, and an exhaust stroke. Air and fuel are mixed and drawn into the cylinder during the intake stroke. The mixture is compressed and a spark ignites it, creating a power stroke that drives the piston down. Here is the pressure and volume graph which represents the all the four strokes. First one is intake stroke from 0 to 1 wherein it goes into compression stroke where the gas air and fuel mixture is compressed and it is drawn out ignition stroke, and the power stroke exhibits all the energy used, and the exhaust stroke exhibits all the energy which is generated. Working principle of CI engines. CI engines operate on diesel cycle which also involves four strokes but with a different ignition method, that is they are compression ignition. Air is compressed first, raising its temperature significantly before fuel is injected. The high temperature allows the fuel to ignite spontaneously and producing power. Components of IC engines. Key components include cylinder, piston, crankshaft, and camshaft. The cylinder houses the combustion process and the piston converts pressure into mechanical motion. The crankshaft translates the linear movement of the piston into rotational motion, which helps in the motion of the wheels and motion of the vehicle. Fuel types used in IC engines. Common fuel types include gasoline, diesel, and alternative fuels like ethanol. Each fuel type has distinct properties that affect engine performance and efficiency. The choice of fuel can also influence emissions and environmental impact. Efficiency of IC engines. The thermal efficiency of IC engines typically ranges between 20% to 30%. Efficiency can be influenced by factors like engine design, fuel type used, that is maybe gasoline, diesel, or petrol, or other CNG gases, and operating conditions depends on the driver. Improving efficiency is a major focus in automotive engineering and technology development. Engine cooling systems. Cooling systems are critical for maintaining optimal engine temperatures. Common cooling methods include air cooling and liquid cooling systems. An efficient cooling system prevents overheating and ensures engine longevity. Lubrication in IC engines. Lubrication reduces friction between moving parts in the engine. It helps dissipate heat and prevents wear and tear on the components. That is, the components move in a easy way where it is lubricated. Proper lubrication is essential for engine performance and reliability. Combustion process in IC engines. The combustion process involves mixing fuel with air and igniting it. Combustion process takes place in the third stroke. The efficiency and completeness of combustion affect power output and emissions. Modern engines employ technologies like fuel injection to enhance combustion. Emissions from IC engines. IC engines emit pollutants such as carbon monoxide, nitrogen oxides, and other hydrocarbons. Emission regulations have led to the development of cleaner engine technologies. Catalytic converters and exhaust gas recirculation are common emission control methods which control the emission and it keeps other air quality same. Engine performance metrics, where the performance of engine depends. Performance is often measured by horsepower, torque, and fuel efficiency. Horsepower indicates the engine's ability to do work over the time, where the torque measures the rotational force, that is the initial power you get in the vehicle, and it's crucial for acceleration and towing capacity. Engine turbocharging and supercharging. Forced induction methods like turbocharging increase engine power without significantly increasing size. A turbocharger uses exhaust gases to drive a turbine that compresses intake air. Superchargers are mechanically driven and provide immediate power boost. Hybrid and electric alternatives, where hybrid engines combine IC engines with electric motors for improved efficiency, where they are mainly built only in the mind that to improve the efficiency of the car and fuel efficiency of the car, and the performance is lesser than compared to other IC engine cars. Now we come to electric vehicles. They operate solely on electric power. They do not have any IC engine. They only have the battery which supplies the power to the engine, eliminating emissions from combustion. The transition to alternative powertrains is a growing trend in the automotive industry. This is the new trend line. Maintenance of IC engines. Regular maintenance is essential for optimal performance and longevity. Key maintenance tasks include oil changes, that is for the lubrication. There is no wear and tear in the components, and filter replacements so that the air cooling does its proper working, and spark plug inspection so that there is no problem in the starting of the car. Neglecting maintenance can lead to reduced efficiency and costly repairs. Future of IC engines. The future of IC engines is influenced by stricter emissions regulations and environmental concerns. Innovations in fuel efficiency and hybrid technologies are being prioritized. Despite challenges, IC engines will remain relevant for many applications in the near future. Advances in IC engine technology. Innovations such as variable valve timing and direct fuel injection enhance performance. Research into alternative fuels and biofuels is gaining traction. Smart engine management systems improve efficiency and reduce emissions. And combination of both electric power and IC engine keeps the car more efficient. And that there's a new segment called hybrid electric vehicles. Comparisons of IC engine with electric motors. IC engines offer quick refueling times compared to electric vehicle charging. That is, we can fuel it up within a few minutes. But whereas in electric vehicle, the charging takes more time compared to IC engines. Electric motors provide instant torque and are generally more efficient than IC engines. Each technology has its own advantages and challenges and cons impacting consumer choice. Case study: sports cars. High performance sports cars are often utilize advanced IC engine technology for maximum output, that is the power. Features like turbocharging and lightweight materials enhance speed and handling of the cars. The balance of power, efficiency, and driving experience is critical in sports car design. Conclusion: IC engines have played a crucial role in transportation and industry for over a century. Continued innovation and adaptation are necessary to meet evolving environmental standards. Understanding the fundamentals of IC engines is vital for future engineers and enthusiasts. This is the last slide. Thank you everyone for watching till now.